We're learning getters and setters in Java. Getters and setters are kind of the start of learning legit object-oriented programming. Generally, when you start learning Java, you're not really doing object-oriented stuff when you're learning for loops and while loops and switch statements and all that. So getters and setters are kind of the start of actually doing object-oriented programming. I'll put some links in the description to some of my other object-oriented videos, and I'll also link to my all-time favorite Java book, which does an amazing job explaining object-oriented programming concepts. I have an empty class open here called getters and setters. And let's say we want to start making cars inside of this class. So I'm going to go to getters and setters, the Java project in Eclipse, and I'm going to make a second class. So I'll name it car, and I won't give it a main method. And this class car is just going to be a blueprint for making cars. And we're going to make those cars inside of our getters and setters class. So if we go into car and we give it some instance variables, let's give it int max speed, int num doors, string maker, that'll just be the brand, and then we'll go string model. Then now we can start making cars that have these attributes, which are called instance variables. So if we go into our getters and setters class, then we can make a car. Let's call it car1. Car1 equals new car. And now we have a car. Let's say we want the user to enter how many doors and the max speed of the car. Let's make a scanner scnr equals new scanner. So we'll have the user enter the attributes for our car1. Let's just say car1 dot max speed equals scnr dot next int. And then we'll go car1 dot num doors equals next int. And let's print out the value of max speed and num doors. Max speed plus car1 dot max speed. And I'll just copy and paste that down, and we'll also print out the number of doors. And this is generally a pretty terrible way to set your instance variables. It is going to work, but for a number of reasons, it's not how you ever want to do it. So if we run this right now, everything's going to work okay. We can enter in the max speed. I'll go 150, and then we can enter in the number of doors, let's say 4. So we have a max speed of 150 and number of doors is 4. So everything worked, but there are a lot of things that could potentially go wrong here. One example would be, say, the max speed is 150 and then the user enters -20. So now our car has -20 doors, and obviously we don't want to allow that to happen in our program. You don't want cars that have -20 doors unless you're in some kind of weird multiverse where cars can have negative doors. So to get around this, we could do something like int new num doors equals scnr dot next int. And then we could just pass that value into car1.numDoors if it is greater than 0. So that would protect us from having a negative number of car doors. And if it's not greater than 0, then we can just write a print statement that says, nice try, but no can do. We cannot have negative car doors. System.out.println, nice try, not enough doors. And then let's just give it an automatic value. In this case, let's say car1 num doors equals 4, which is a reasonable amount of car doors. So if we go 150 and -20 again, then we get max speed 150 and number of doors is 4. The issue with writing out our code like this is that every single time we want to set num doors, we're going to have to confirm that the number of doors is greater than 0. And there might be a lot of other validation that we have to do for our other attributes. And every single time we alter one of those attributes, we're going to have to validate that info. Not to mention, it might not be us who is actually editing the attributes for objects of our class. If we're working on a project with someone else, then someone else could come along and say, hey, I'm going to make some cars, and they could forget to validate the info. So a much better way to do this is just to validate the info inside of the car class, and to not let anybody enter any info that doesn't meet our specific validation requirements for our car's attributes. So if we go back to getters and setters, we can get rid of this if-else logic here. And we'll just go back to something similar to what we had before, but it's going to be slightly different this time. So we have car1.maxSpeed equals next int. We'll deal with that after. Right now, let's just deal with the number of doors. This time I'm going to say car1.setNumDoors, and then we're going to pass it in the value that gets scanned in by the user. So now we can go into our car class and we can write setNumDoors, which is just going to be a method that sets the number of doors. So if we go public void setNumDoors, it's public because we want this method to be able to be accessed outside of the car class. So we want to be able to access this method from inside of our getters and setters class. So that's why we're making it public, and it's void because it's not returning anything. It's just going to take in a value and set the number of doors for this car to that value. So our parameter is just going to be that value. We'll call it numDoors. And then inside of setNumDoors, we're just going to set the number of doors for this car to the number of doors that got passed into this method. And right now we actually have two versions of numDoors, which is kind of cool. We have the instance variable numDoors, and then we have the local variable numDoors, which is the one that's getting passed into this method. And to specify which one we want, for the numDoors instance variable, we're going to refer to it using the this keyword. So we're going to say this.numDoors. This just means refer to the instance variable of this object. So this.numDoors equals numDoors. And the second numDoors is our local variable, the one that doesn't have the this keyword in front of it. And I should specify that numDoors is an int. So this is what a setter looks like in Java. That's all there is to it. And we always want to set our instance variables to private. That way we're not allowing anybody to set our instance variables the way that we set them before, where you could all of a sudden just make a car have negative 20 doors. So now that these have private in front of them, if we came into here, and actually it's already highlighted, we have a mistake because we set it to private. So now in here, when we tried setting car1.maxSpeed like this, then it just says, no, you can't do that. And if we hover over it, it says the field car.maxSpeed is not visible because we set it to private. And when you set it to private, only this class itself can view and change that instance variable now. The only way that any other class can change it is through setNumDoors. So the car class is the only class that can change it directly, and any other class has to use setNumDoors. And now inside of setNumDoors, we can put that validation that we had before inside of our getters and setters class. We can just say if numDoors is greater than 0, then set the number of doors. Else we can just give it a default value and print out the same error message that we printed before. So we'll say this.numDoors equals 4, and then we'll just print out nice try, not enough doors. And since the only way to change the number of doors for anyone outside of this class is to use setNumDoors, then any code that changes the number of doors is forced to go through this validation now before the number of doors gets changed. But now we have another issue, which is that we also can't access the number of doors like this. So we can't say car1.numDoors because numDoors is private. It can only be accessed inside of the car class itself. So now we have to say car1.getNumDoors, and then we're going to write a getter method inside of our car class. So we have car1.getNumDoors, and we'll go car1.getMaxSpeed here. And we'll write the numDoors manually, and then we're just going to really quickly do something awesome that Eclipse can do, which is automatically write getters and setters for our max speed and all of our other instance variables. So if we go back into car, then we'll write our get num doors, just so we can manually go through what it actually looks like writing getters once, just for get num doors. So if we go public int get num doors, and it's an integer this time because it's going to return the integer value that is the number of doors. And it's really simple. We just need one line of code. We go return this dot num doors. And we don't even need the this keyword in there. I like putting it in there just because it makes it extra obvious that num doors belongs to this object. But this time it would work just to say num doors because we don't have a local variable num doors being passed in. So we have return num doors. And now this is our getter, and the getter can be used from inside of our getters and setters class. So we'll go car1.setMaxSpeed and scnr.nextInt inside of it. And then we're just going to automatically get Eclipse to write out the rest of our getters and setters for us. If we go to source, generate getters and setters, and then we can just highlight whichever ones we want, which is all of our remaining instance variables. And then we hit generate, and Eclipse just made all of our getters and setters for us. Getters and setters in other programming languages are called accessors and mutators. Sometimes in Java, people will refer to them as that too. So accessors and mutators are what they're sometimes called, accessors being the getters and mutators being the setters. And this whole idea of putting our instance variables as private and then using public getters and setters is called encapsulation, which is referred to as one of the three pillars of object-oriented programming. You have encapsulation, inheritance, and polymorphism. So what we're doing right now is actually legit object-oriented programming. Lots of the time when you start learning Java, you're usually not actually doing object-oriented programming, even though Java is an object-oriented programming language. So this is actually legit object-oriented programming now. And we'll make it more legit in a second. So let's just run this first, make sure everything's going okay. So we can set our max speed to 150 and put 10 car doors, and let's try it with a negative number now. Max speed 150 and negative 20 car doors, and nice try, not enough doors, and it just sets the number of doors to 4 for us. Right now, let's make this more legit. Let's make a constructor for car. So when we made our car originally, we just said new car, and this car part here with the parentheses following it is the constructor. And we didn't actually write a constructor method inside of car, so what happened is Java just automatically used a default constructor. It just said, okay, you want to make a car, but you haven't actually made a constructor method for a car, so you can just use the default constructor. But what we want to do is we want to be able to pass in the values for our instance variables when we make the car. Kind of like up here for our scanner, how we said make a new scanner and pass in system.in as the parameter for that scanner. We want to be able to do that with car, but we want to pass in our own instance variables. So we want to be able to say max speed 150, and the number of doors is 4, and the maker is Toyota, and it is a Camry. And right now we're getting an error because it's saying, hey, there's no constructor method for car that takes in 4 parameters for the value of the car. So we're going to go write one inside of our car class. To make a constructor, we just type public and then the name of the class. The name of our class is car with a capital C, and then a set of parentheses. And now this is a constructor that returns a car. So this class itself is just like a blueprint for making cars, and every time the constructor gets called, then a car is going to get popped out. So if we go public car, and then we're going to pass in those parameters that we wanted. That was int max speed, int num doors, string maker, and string model. And inside of our constructor method, we're just going to set the values for this instance of a car to those local variables that just got passed in here. And your first thought might be, hey, let's just use the getters and setters that we made. We can use the setters to set the values for the car, which is a totally reasonable thought, but isn't a good idea because those getters and setters rely on already having an instance of a car instantiated. And what we're doing right now is actually instantiating the car. Java will let you actually call those methods from inside of here, the getters and setters, but it's generally not a good idea because stuff can go wrong. So instead, we'll just put any validation code for the car's instance variables inside of the constructor as well. So we're going to have the validation happen in two spots, in the setter method for each instance variable and in the constructor for the car. We haven't written out any validation for our other instance variables, so for now I'll just set the instance variables for the car to those. So we have our max speed, again, which we're going to refer to with this keyword, just saying that this version of max speed is the one that belongs to the object, and this one is the local variable that just got passed in. So we have this.maxSpeed equals max speed, and then we'll go this.maker equals maker, and this.model equals model. And then I'll just copy and paste the validation code that we had inside of our set numDoors. So I'll just copy and paste that and put that inside of our constructor. And now our constructor is going to validate the value for numDoors before it actually assigns that value into numDoors. So now if we go back into getters and setters, we have car1 equals new car. Let's change this to car2 actually. So we'll have two cars. Car2 will instantiate using our 4-argument constructor. And car1, we're going to try using the default constructor that we used before. So car1 equals new car. But now we're getting an error and it won't let us use that constructor because Java says, hey, you wrote a constructor for a car, so you don't need the default constructor anymore. You're already taking care of writing your constructors. So now we don't have access to the default constructor for car. So we're going to want to write a second constructor for car that takes in 0 parameters. And this is called method overloading. When you write two versions of the same method that just take in different parameters. So this version is our 4arg constructor. It takes in 4 arguments, 4 parameters. And now we're going to write a noarg constructor. So we're just going to go public car and have it take in no parameters. And in here we can just put default values for the car. And we'll just say this dot max speed equals 150. This dot numDoors equals 4, and the maker is unknown, and the model is also unknown. So now we're setting less limits on anyone who wants to make cars. We're saying, hey, you can make a car without passing in any parameters, or you can make a car and pass in all of the parameters. So let's just print out the values for these cars now. We have the max speed and number of doors for car1, so I'm just going to copy and paste that down. I'll go car1 max speed, car1 number of doors, car1 maker, and we'll go get maker. And car1 dot model, and car1 dot get model, and then I'm just going to copy and paste all that and write it the same for car2, and we'll print these out and make sure our car is actually instantiated correctly and have all of the proper values for them. So we put in our input for the first car. We just have to enter the max speed and the number of doors. Let's give it 22 doors. So car1 max speed 150 with 22 doors. The maker is unknown and the model is unknown because car1 was made with our noarg constructor where we said maker and model unknown, and then we didn't bother to set a maker and model for it. We just set the max speed and number of doors. And then car2 was made using our 4arg constructor, where we passed in 150 for Toyota and Camry. So there we get 150 for Toyota and Camry. That's it for this video. Thanks for watching. I'll put some awesome resources in the description just to some of my other Java videos and to some awesome books for anyone learning Java. Thanks for watching.